It's a good start. Our panel this morning, Stan Butchart, naval aviator, highly decorated World War II in the Pacific, spent many years at Boeing and NACA, flew the B-58, the X-4, the X-5, the B-47, B-52, KC-135, and on and on. He was chief test pilot at Dryden, OPSO there for 10 years, supervised the X-15 program. That's Stan Butchart. Fitz Fulton, pilot of all aircraft ever, I think. But he's here today to talk about the B-58. Rob Rivers, who's an engineer and test pilot currently at Langley as a research pilot, will talk about the Concorde and doing analysis of the Tu-44 and the Concorde handling capabilities. Guy Townsend, Air Force Brigadier General, retired, highly decorated World War II aviator, Air Force test pilot, chief of bomber test at Wright Field, first flight on the B-52, and was test director on the XB-70 and other aircraft. And finally, Al White, Air Force test pilot. He was chief test pilot at North American, project pilot on the F-100 CNF, was chief test pilot and project pilot on the XB-70. This is our panel this morning. Welcome, gentlemen. Stan, to start, we'll go chronologically. B-29, but you had to adapt to the B-29 for what you used it for, yes?
Yes, sir.
How did you do that? What did you have to do? What did you do with the B-29?
Well, I think, is mine on too?
You are.
On. I think I'm going to be speaking a little differently than the other gentlemen in that I was not involved with the testing of the B-29. The remarks I want to make deal with our operational use of it, as we had the Tu-29s for motherships to carry the skyrockets and the X-1 series aircraft. NASA inherited the B-29 800, 800. I think Fitz flew it many times, probably when they were Air Force was launching the X-1 series, X-1, and then X-1A and the B beside the X-1. I think we inherited them in probably '54 when the Air Force turned over the X-1A and the X-1B to NASA. But to back up a little bit, when I first joined NASA, I was a single-engine Navy pilot, had been flying TBM for about 8 or 9 years, and Douglas was just finishing their demonstration flights on the Skyrocket, B-58-2, and they finished their last flights Bill Bridgman was flying at the time, probably in May, June of '51, and I had arrived in NASA in May. And a couple weeks later, Crossfield checked me out in a C-45, and that was kind of an experience with Crossfield checking you out in an airplane. But a month later, George Jansen, who had flown the B-29 for Douglas during the demonstration, called up Joe Walker and I and invited us over, and we went out and flew it for an hour or two, made some landings on the South Lake bed, and we were B-29 pilots. Joe flew the first few drop flights, and then he turned it over to me, and I had it for the next 5 or 6 years. And in a way, the operational procedures through the day were a little bit like I've heard airline pilots say, that it's hours and hours of boredom with moments of stark terror. Well, I'll just kind of describe what our operation was like. We did not have the radar and the control room and all that we have today. Basically, I operated as NASA 1 in the B-29, conducting the flight from the pilot's seat. And the research pilot would be up in the cockpit area with us at takeoff, and he'd finish getting in his pressure suit and crawl back in and get in the airplane somewhere around 8,000 or 9,000 feet. And about that time, I would turn it over to the co-pilot and let him fly, and it was an hour, 20, hour, 30 minutes of just grinding to altitude. And we'd get up 31, 32,000 feet, 35 some days. But the one day I want to talk about was the first flight, or the second flight actually, of the X-1A. Joe Walker was flying the thing, to fly the thing. And research engineers, I don't know, understand why, but they each had a different place they wanted the different research airplanes drop. One of them was over Rosamond, or west of Rosamond. One was west of Lancaster. One was southwest of Palmdale. But the X-1A, they wanted dropped out by Victorville. And so we spent our hour, 20, 30 minutes climbing to altitude. And the part that I kind of disliked the most was by the time we got to 32,000 feet, I had to send 2 crewmen. We carried 3 crewmen in the back that were a rocket engineer, the mechanic, and 2 crewmen for the airplane. They had to go back out into Bombay and disconnect the top-off tube out of the X-1, or the X-1A in that particular day. And I always turned around to watch that operation because they were carrying about a 20-foot piece of oxygen tube hose with them. And I wanted to make certain that they got out and got the job done and back in good. Things were kind of quiet from the time you were flying from 15,000 feet to 30,000 feet. Not much to do but grind away. And that poor B-29 took a beating. We were at climb power for an hour and a half. Engine temperatures, the red line on the cylinder head temperature was right at the top most of the time. Although I did find out that right after takeoff, if I would lower the nose and just let it cool off a little bit, you could go back to climb power and the temperature would stay the same place. On this particular day, I would pick a spot that was 6 minutes from where I wanted to drop it and call a 6-minute point, and then the things got busy again. Joe was going through checklists and setting pressure gauges and doing all the work he had to do, and I'd call out the 5-minute and 4-minute and all the way around. We'd do 2 minutes out, 2 minutes in a turn, and 2 minutes back to the drop point. And when I hit the 1-minute point, Joe, his operation was to hit a switch which dumped that 3,000 or 4,000 psi nitrogen gas to pressurize the engine and the tanks rather, and we had an explosion. I mean, a terrific explosion. I thought we'd hit another airplane momentarily, and Kit Murray was flying chase, and he said, "You got a fire." Well, we kind of had an unwritten gentleman's agreement with the pilots that the trouble in the X airplane, we would drop whichever airplane had the problem, we'd get rid of the 2 so they'd fight their battle by themselves. And the 2 of the crewmen that had board crawled back inside and helped Joe get out of the cockpit. He was rather stunned at the time, and of course he was without oxygen, and he crawled up into the cockpit area where we were, and I was able to give him my oxygen hose for a while to get him going until we could locate another one. And the fire didn't last long because, of course, when you're at that altitude, there's not enough oxygen to support it. But from then on, it was a game of figuring out what we were going to do. I wanted to try to land with the thing, but they'd blown the gear doors blew off, the gear blew down, and with the gear down, it's hanging down lower than the B-29 gear. But I thought, well, it'll squash back up when we land. But my boss...
So what did you do?
Well, they told me to get rid of it. So I asked, okay, where do you want me to dump it? And they gave me an assignment of the PB6, which was a target over the other east side of the rocket site. And I dumped it on the desert. In the investigation, I thought was very interesting because they recovered all the parts there, and in examining the liquid oxygen tank, they found residue of a substance called TCP, which had been used in the gasket that sealed out the manhole in the back of the liquid oxygen tank. And it turned out that small quantities of TCP in the presence of liquid oxygen are pressure sensitive. So when he turned on that nitrogen gas, it was a water hammer-like effect, and it blew. And that was the same thing that had happened on the X-1D, the X-1 number 3, and one of the others, I forget which.
But you all survived this.
We got back and made it, but that was kind of a typical day.
Guy Townsend, B-52, first flight, what was expected from the airplane and how did it go?
First flight was on 15 April 52. It was a tandem airplane, and we wanted to check out the systems in the airplane. The airplane had a very unusual system. It had no engine-driven alternators or hydraulic pumps. We bled air off of all eight engines and turned and fed 10 turbines that ran generators and ran alternators and also hydraulic pumps. And there were a lot of people worried about this system, and so we had a backup system in there. We had 7,000 pounds of batteries, and the electrical boys had actually parallel 10 inverters, which actually theory says you can't do it, to form the electrical system, and there's a backup system, and with those 7,000 pounds of batteries, that's enough power that if you dropped a 12-inch crescent wrench across the main bus bar, and it would melt and run out to Bombay. And we didn't have to use that system. We flew for 2 hours and 15 minutes and landed at Grant County, which was Moses Lake at that particular time. And on final approach, the Air Defense Command scrambled two F-84, two fighters straight into us on short final. And the aerodynamic people had been worried about aileron overbalance. We had a spoiler system in there and two small field ailerons in there, and they had put the spoiler pickup point at 20 degrees, and the stick forces were so high that Tex was in the front seat and I was in the rear seat. It took both of us to hold the airplane as we went around. We went in and had the post-flight meeting and had the press all there and everything, and then when they all cleared out, and the project engineer, Art Carlson, said, "All right, now tell us what really happened." And so Tex said, "Well, Art, the first thing you got to do is you got to go get Guy and I some more new flying suits." And he said, "Gee, Tex, you got brand new flying suits right now." I said, "What's the trouble?" He says, "But these flying suits have got to have legs in them as big as our arms, because if we have to fly that damn thing the way it is right now, our arms are going to be as big as our legs." Actually, everything worked pretty doggone good on it on the first flight, with the exception of that. All you had to do is put the spoiler pickup point at 2 degrees instead of 20 degrees, and take some conservatism about the aileron overbalancing. And the alternators worked real fine, and it was a very successful first flight. And I was very honored to be in the position I was in. Normally, you would have had 2 Boeing pilots flying the airplane, and I realized that I had to really, to be able to do my job right, I had to get the confidence of the Boeing company so that they would wash their dirty linen in front of me, and I wouldn't tell the Air Force everything I heard. And I managed to do that. I'm real proud of that. And I'd like to go on to the next subject, really, and an interesting deal, and the title of this is the stupidest thing I ever did. And we took the airplane and we took the X down to Edwards and to run on the thrust stand down there, and I wanted to do a long-range flight. And so it was in the middle of the summertime, and we had those miserable partial pressure suits on, that the criteria is that if it's comfortable, it's not fit, if it's comfortable, it's not tight enough. And so it was in the middle of the summertime, it was an old base, so I figured I'd take off on the lake bed, and I didn't really have to worry about the temperature, and the airplane kept sliding and sliding and sliding. It was a hot summer day. Had the 8,000-pound engines in those on the airplane. I said, well, we got plenty of runway out there. And they kept getting hotter and hotter and hotter. And finally, the temperature was up to about 105. And we started the takeoff roll, and we rolled 15,800 feet. And takeoff velocity was 152. It came airborne right exactly at 152 like it was supposed to. Sucked up the landing gear, and number 3 engine let go. And a catastrophic failure in the engine. And on that particular airplane, the drag is twice as high at half flaps as it is with full flaps. And when the gear can't come up, the alternators were in the front wheel well, and Gus Julian was chasing me, and I had a maximum velocity I could do in-ground effect of 154. Remember, I got airborne at 152. I couldn't pull up the flaps, and I turned around real slowly and started to Roseman Lake. And I said to Gus Julian, and the fire warning lights all came on in the forward wheel well. And I said, Gus, check that forward wheel well. And he says, he started to go under there, and there was a Joshua tree in the way. and so he said, Colonel, says, why don't you climb up a little bit so I can get under there? And I said, Gus, what the hell do you think I'm trying to do? So we fly all the way out to Roseman and around Roseman and back to Edwards, and I was at 150 feet. It took 45 minutes to get to 1,000 feet, and so I could pull up the flaps. And Von Blumenthal, who was the chief engineer on the airplane, said, Guy, you didn't prove but one thing. And I said, what's that? And he says, you can get airborne when you shouldn't be airborne. And he's dead right. You know, actually, to wind up my particular story on the airplane, you know, the airplane is in the war plan through 2040. And that is really tells you what the airplane was. It's a fantastic airplane, and I've spent the majority of my life trying to think about how to drop something on somebody's head. And when I can look at the TV and see a B-52 in Iraq, Afghanistan, circling around up there with 16 JDAMs on board, and the ground support people, or rather the Special Forces people, say that they won't shoot at me as long as they can see that airplane up there, I think we've succeeded real well. Thank you.
Fitz, I read you quoting you that you wrote that the B-58 was an airplane before its time. What does that mean?
Well, I guess one thing, it's my favorite airplane to start off with, but it really was well before its time. The airplane flew 47 years ago, and you know, it's still as pretty an airplane as there is in the air. Well, it's not in the air anymore, but to look at. But the airplane was an unforgiving airplane. It was could fly at Mach 2 at altitude or 600 knots on the deck, but it required a lot of attention as far as the pilot goes. It had a lot of problems that were eventually worked out, became a good airplane. But
slide up, put the slide up for the B-58, please. Go ahead, Fitz, sir.
Well, the first 2 years of testing the airplane, we didn't lose any airplanes. The third year, we lost 7. So, you know, that would slow most anybody down. But the first flight of the airplane was in November of '56. And I flew it 3 months later on what I'd hoped would be the first Air Force pilot to fly the airplane. And I went out twice to fly it, and one time had fuel leaks, another time had some kind of a problem even after I got started and was ready to taxi. And it took a lot of discipline to turn that airplane around and not take off, because I knew General Boyd, who was the Air Force Chief Test Pilot, was coming 2 days later to fly it. So General Boyd came. The airplane didn't dare have a problem then. He flew it. 2 days later, I flew it. But it's a 163,000-pound airplane with 1,500 square feet of wing, so it's heavily loaded, over 100 pounds per square foot, and had full dampers, dampers on all three surfaces. Had a very sophisticated, complicated longitudinal system. Anytime you pull the stick full back, you should get limit load factor, and that was 2 Gs at heavyweight, 3 Gs at lightweight. So the theory was that you pull back and you'd never exceed the limit load factor. Well, that didn't work out quite as well as they hoped, because it had an elevator ratio changer in the system, which would change the amount of elevator that came in. You pull the stick back at 0.9 Mach number, you'd only get 0.8 of a degree of elevator, because that's all it was allowed. Later on, it had to be changed to have more. But all that was run by what we call the PCLA, the Power Control Linkage Assembly in the back of the airplane, 3x3 assembly with about 1 foot high, which had bell cranks, push rods, cables, hydraulic lines, reset handles, everything, fuses, everything you can think of. And any pilot who flew it and said he understands that unit back there was wrong. I flew it for 800 hours, and I never did. All I knew was how to look up there and see if anything was leaking out. But the key to flying that airplane long range and getting the most out of it was flying with a low static margin. In other words, about 3% static margin was ideal. We flew sometimes as high as maybe 1%, I mean as low as 1%. But when you went supersonic, of course, you got to move fuel aft to get the elevons down. So once you go supersonic, you move this CG 4 or 5% aft, and then get rid of some of the elevon trim drag. And then when you come subsonic, you better move the fuel forward again, or else it's going to be unstable. And there were a couple of cases where people almost lost the airplane like that. But the
Fitz, you set a bunch of records. What, there were some 19 speed and altitude records?
Well, I didn't set just 2 records, but I'll cover that a little bit here. We had what we call the vertical sidestep maneuver. I don't know who got that name, but that was a deal where you come in fast at high altitude and pull up to change altitude. The theory was that the Soviet radar at that time would lose lock for rapid altitude change. So we developed a maneuver where you come in at 50,000 feet, Mach 2, pull up about 25, 30 degrees pitch attitude, zoom up, and then go over the top at about 75,000 feet. And we developed that maneuver for the SAC people. And one of the things that we determined was, after we worked out the maneuver, that we thought we could set a record. So we got approval, got all the authorities there to approve it. And it came in, instead of Mach 2, the limit, we were 2.18 Mach number at the pull-up at 54,000, pulled up to 30 degrees pitch attitude, and at about 70,000 feet, the afterburners blow out, and then you start pushing a little bit. We wanted to be supersonic over the top because we were afraid of a pitch up. We went over the top at 1.01 Mach number, and but the afterburners blew out, and the engines would tend to overspeed above 80. So we had a cut number 1 and 4 engine at 80,000, and number 2 and 3 we had set lower min fuel flow so they didn't overspeed. But anyway, we came over the top and come down the backside. We were able to hit 85,360 feet on that flight, and I think I'm sure that's the highest the B-58 ever went, but that was just 2 records. I'd like to cover a couple of test points that we had. One of the things, the tires were very, very weak on the B-58 at the beginning, and there were several cases where the tires blew out. And I was doing a 3-engine takeoff where we went to the decision speed and cut number 4, and it was near max gross. And at the time, the tire blew out, and then it's kind of a chain reaction. 7 of the 8 tires on the right side blew out. We were going too fast to stop. I could see rubber going by, but and it put about 50 holes in the airplane. But we continued to take off and lost 1 hydraulic system, and of course couldn't pull up the gear. And we climbed on up and about 8,000 or 9,000 feet, floated around deciding what we're going to do. But my good friend Charlie Bach got in another airplane and came up and looked at it. He was qualified in the 58 too, and he said it looked a little ragged. So anyway, we jettisoned the canopies, to the aft canopies, burned out the fuel. Well, another thing on the hydraulic system, I lost 1 hydraulic system, and while we were floating around, we looked down, the other hydraulic system had gone to 0. And of course, it's a hydraulic flight control system. I told the crew, I said, we may have to get out, and I moved the stick, and everything worked. It worked out. A hydraulic fuse had blown, so we were able to continue flying. But anyway, we came back, they foamed the runway, we landed on that. But the thing that leading up to here is that as a result of that, we decided to develop what we call the non-frangible wheel. On the B-58, you got 4 pair of wheels on each side, and they got 2 tires on each rim. And we developed a system where they had a flange in between, so if the tires blew, you could run on the flange. And so we did about 100 taxi runs developing this flange. We looked at the steel flange, magnesium, cast aluminum, forged aluminum, everything you could think of. We finally can end up with cast aluminum, a special alloy. And on these taxi runs, we eventually, once we got which type we wanted to use, we would go out to about 50 knots, blow the tire had a 20mm cannon in the guard over the gear. We'd blow the tire and then see how the flange went. Once we got it fully developed, I made the only solo flight ever made in the 58. We accelerated to 50 knots and blew the tires, continued going to 225, running on the flange, got airborne, came back, landed, and that flange was put on all operational airplanes after that. And I felt very pleased about that because I felt we'd contributed a lot to safety on the airplane. But
by the way, Fitz won the Harmon, by the way, in 1962 for flying the B-58. So
how's my time?
We're in time trouble, Fitz, to tell you the truth. I'll be honest, it's not your doing. It's just we're trying to put a lot of material in.
Why don't we press on, and if we have time, I'll come back.
Okay, that's great. Al White, everybody here knows when the government wants to buy an airplane, they establish criteria. True for the XB-70, but true for other airplanes as well.
I have a copy of a document here that's a purchase order that was written in 1908 for, I'm going to read this, for one heavier than air flying machine in accordance with Signal Corps Specification 486. This was issued by the War Department and by the Chief Signal Officer. In those days, I guess they didn't know the value of airplanes as weapons. They were using them as message carriers. I don't know, I guess the messages were too heavy for carrier pigeons, so they had to have an airplane. So this specification for this airplane was going to cost $25,000. They asked that the airplane be capable of disassembly carried around in a truck, then reassembled within an hour. The speed qualification for the requirement for the airplane was 40 miles an hour. If it went 39 miles an hour, they lost 10% of the contract. If it went 38, they lost 20%, down to 36 miles an hour, and if it couldn't do that, they canceled the contract. On the other hand, if it went 41 miles an hour, they got a 10% bonus. Now we go from that, if we're talking about history, we go from that for 50 some years later, we come to the XB-70. Now the speed requirement is 2,000 miles an hour versus 125 for the Wright airplane. The Wright airplane was required to have 2 people and not to exceed 350 pounds. I think we flew the B-70 with just 2 people, and I suspect that we exceeded the 350 pounds. The $25,000, I won't even talk about the price of the B-70. I think you could buy one for $25,000. And you sure couldn't disassemble it in an hour and put it in a box and haul around on a truck. There is one thing, there's one common feature about the 2 airplanes, though. The Wright airplane, as you might recall, had the longitudinal control system was a canard. The B-70 also had a canard. I think probably in this country, one of the first airplanes that had a canard after the Wright brothers airplanes. Now, if I could have that first picture up there, the canard on the B-70 was not used as a flight control surface. It was used in 2 ways. We had flaps on the back of the canard, which allowed us to trim the elevons down on the back of a delta wing and in essence have flaps on a delta wing. That's the wrong one. We want to go the first one at the other end of the chain, please. The one that shows the takeoff, if you could do it. Anyway, having the flaps on the canard and then trimming the elevons down gave us low takeoff and landing speeds. But the canard at cruising speed was used as a trim device. It was the longitudinal trim system. It was fixed with the flaps down, but when we took the flaps up, it was a trim system, and that reduced the trim drag for the airplane, because with proper fuel management, we could keep those elevons back there streamlined and reduce the trim drag. I wish we could have that middle one now with the airplane in flight.
No, you can't come up with them. Oh, that's too bad.
Okay, the airplane had some good aerodynamic features. It had a windshield ramp that we could streamline, which reduced the drag. We had the canard value of that at high speed. We had they used a system called compression lift, which meant that the shock wave created by the splitter at the forward of the underbody the wing was shaped to fit right over that shock wave, and that wing picked up a considerable lift riding on the pressure field behind the shock wave. It had drooped wingtips. We put the wingtips down, which increased the directional stability. So aerodynamically, it was a very efficient airplane. It had a lift-to-drag ratio at Mach 3 of about 8, which is very good for a big airplane like that. Truthfully, I'll say that we had a few problems along the way, but it was a great airplane to fly. Talk about one. Fitz and I were flying it one day. We were up at about 2.6 or 7 Mach number, someplace up around 66,000 feet. And all of a sudden, the number 5 engine went way overboard on vibration. I shut it down, confused the hell out of the situation, because now we had too much air going into that duct, and Fitz had to quickly open the bypass doors and stop the duct buzz. And about that time, the other 2 engines went overboard. shut those down, and then we really got duck buzz. And Fitz solved that by, the co-pilot over here had the control of those inlet ducts, so he opened the bypass doors, got rid of the pressure, and we solved the problem. And they were coming down, and the airplane had a feature that the engine people required was above 1.5 Mach number. There were fuel control devices that held 100% RPM of the engine. But when you went below 1.5 Mach number, if you had the throttles back at idle, which I did, the engine's unspooled. And so here we are with 3 engines out, a whole bunch of lights up there, and all of a sudden 3 engines on the other side unspool, and I reported that we lost the other 3, which really upset a few people down on the ground, I guess. Fitz and I started air start one of them. He was looking at the panel, and he realized that the number 1 and all the engines on that side were really running. They were just at idle. So he pushes up number 1, and I get into a big yawing oscillation, and we struggled around there. Pretty soon we got it all sorted out and flew it back on 3 engines, which is a testimony to what a good airplane it was.
And also, it's an unusual situation because there are only 2 of these aircraft built, and the one that remains, of course, is in Dayton now.
Yeah.
Quite a sight.
I want to show, if you can go back to that picture with the
landing?
With the landing.
With
now.
the chutes?
Yeah.
Can you go back to the drag chute landing shot, please? There we go.
I want to tell you, and I'll make this very brief, that probably, I love that airplane in the air. It's a beautiful airplane. I think that's my favorite shot because when you're in that position, all you have left to do is taxi in, debrief, change your shorts, and go get a beer. Thank you.
Rob Rivers, how much did you, in doing analysis on the Tu-44 and the Concorde, benefit from some of this stuff that you're hearing today, especially these last 2 airplanes?
Well, I benefited because the airplanes came into existence, leveraged off a lot of the technology of what these gentlemen did. The Tu-144 the Soviets were inspired to go that route of a supersonic transport based on the success of the B-58 in sustaining supersonic cruise. And if you look at the picture of the B-70, you see the canard technology on the B-70 similar to the Tu-144. You see the visor similar to what was used in the Concorde. Certainly they came about these things perhaps independently, but you do see the lineage of the aircraft development. The interesting thing about the Concorde and the Tu-144 as the world's only supersonic transports was there were 2 independent programs developing those in the British and French and the Soviets over many, many years with entirely different backgrounds getting them to their final culmination of flight. Both airplanes flew within a month of each other. Both airplanes first went supersonic within about a month of each other. Both airplanes weighed just about the same. Tu-144 was slightly larger. Both of them had about the same specs. Tu-144 slightly faster. Concorde slightly better range. But it's amazing when you look at all the genesis of these 2 programs to end up flying almost in the same exact time period was quite amazing.
Gentlemen, in the interest of time, thank you all for this session. We've got to move on to other things. Thank you. Thanks, Jan.